Hello, everybody. Welcome to the live stream. It's the first live stream. I've got a whole bunch of gadgetry. In a future live stream, I have a handheld camera, and I will show you how it all works in my studio. Hopefully, everything is running well. I'll just I'll just talk a little bit, and then I'll start with the presentation. Let me get my slide queued up here. There we go. Start with the presentation. So. Let's see. This part of what this talk is I gave this talk a number of times in India, 10 days, 5 cities, 9 schools, 3 companies, and it really is to launch the C Programming for Everybody specialization on Coursera, which is my specialization based on this wonderful book by Brian Kernighan and Dennis Ritchie, and so I spent 4 years on and off building this course, and I wanted to go to India. India is about 1/3 of the technical demand for courses on Coursera, and so that meant a lot to me. I went to, like I said, a lot of universities. Here's a plaque. I've got a couple of plaques to go put on the back on the wall after I get done with all this stuff. I'll put the plaques up. So the outline for this is that I'm going to give a presentation for about 30 minutes, and then I'll just stop for questions and answers, and I'll be looking at the YouTube chat for the questions and answers. Okay, so without further ado, let's go ahead and get to the materials. Let me set my screens up here. Yeah, there I am. I like to put myself in the lower corner. There we go. So welcome to my talk on a programming career for everybody, navigating the path to mastery. My name is Charles Severance. I'm a professor at the University of Michigan School of Information, and I teach the world's largest programming class, Python for Everybody. A lot of you have probably seen my Python for Everybody class. It's really very, very impressive and meaningful to me how many people come up to me and tell me how their lives changed because they took a Python programming class. And as you'll see in this talk, I want to get to the point where I'm creating even more sophisticated programmers. I've gotten pretty good at creating beginning programmers, and now I want to create what I'll call master programmers. So here we go. I have been doing this online, on TV, on whatever, for a very long time, since I even had hair, right? And so back in the late 1990s, I was on television. I really wanted to take what I loved so much at that time was my computer science education, the emerging internet, and I just wanted to demystify it for people. I wanted to show people how it could be used and how this internet could be used, and my co-host Rich Wiggins and I, we basically spent all of our time saying this is easy, this is easy, this is easy, you can do it. And so before there was the term influencer, I just wanted to be a television-based influencer. And my YouTube channel, Dr. Chuck, is hit 100,000. Pretty soon I'll have 100,000. The YouTube plaque is on the way, and I've started this new Dr. Chuck Plus. And if you're watching this video, you are watching it on Dr. Chuck Plus. And the idea of Dr. Chuck Plus was my main channel, youtube.drchuck.com. People expect that to be educational. They expect there to be no ads. There are no ads. I make no money off of that channel, even though there's 100,000 subscribers and tens of millions of hours of viewing, because I believe that education should be free. So plus.drchuck.com is just my fun place, and it's where I'm going to do these live things so as to not clog up my other channel. Where if you want to subscribe to youtube.drchuck.com, do so to get, like, when I put up a new lecture for a new class that's, high quality curated content, that's going on youtube.drchuck.com. If you want to see what I'm doing with a race car, you can go to plus.drchuck.com. I'll try to keep my posts to one a day on plus.drchuck.com. So the key in this talk, it's really a tale of 10 years and 2 textbooks. I don't even have a copy of the other textbook, but I already showed you the first textbook, which is the C programming language with Brian Kernighan and Dennis Ritchie. And the other is the Python for Everybody textbook that I wrote in, am I seeing myself here? Yeah, there we go. My Python for Everybody textbook that I wrote in 2008, 2009, and then went on to Coursera in 2013. And so it's important to understand why I name everything, at least so far, with the word everybody in it. And I've always wanted to outreach to the average person in the public. And I just want to teach everybody. I want everybody to know what the joy that I feel when I write software and build cool things. And so everybody can go all the way from a 13-year-old who just took a Scratch course and they want to learn something a little more deep, all the way up to a retiree who was a lawyer their whole life, and now they've always wondered what technology was, and they want to take a course. And so this has been a journey. When I was in India, for example, I talked to a lot of people in India, and it was surprising how many older people would say, Chuck, I took your course. Like presidents of universities, chancellors and pro-vice chancellors, those folks would be like, I took your course. And I'm like, wow. And so it's not just college students taking these courses. It's people in all walks of life who understand that if you're going to be a university president, you actually might want to know something about programming. Because increasingly all the students, a large fraction of the students want to come and take a computer science or programming or whatever. And so if you're a college president and you don't have a good understanding of computer programming, you need to fix that. So that's where everybody comes in. It's just there is nobody that shouldn't know something about programming regardless of where you're doing. So the most popular programming course in the world, the most successful with over 3 million graduates, 1 million of which are in India, was created in 2013, a year after Coursera was founded. It is now the most popular programming course in the world, translated into lots of languages. You don't even have to install Python. You can do it all in the browser. And has all these auto-graded exercises, and it's way more than a course, because for me, I want you to understand the human context in which we operate when we're doing software development. All these programming languages were built by people. And I also want you to understand that there are other students around the world who are also taking the same course material. And so part of its success was it was not a first computer science course, it was a first programming course. And when the Coursera came out in 2012, 2013, it was very exciting times, and lots of schools and their computer science departments rushed to build specializations and courses. But they all just took the material that was suitable for their on-campus computer science majors, and they just put that up. And the problem with doing that is that they kind of have lost the idea that some of the students coming into computer science, a lot of students coming into computer science, are actually pretty skilled already, and so you give them their first class, but it's really not really a first class. It's their third or fourth or fifth class. And so computer science folks say, like, here you go, let's start here, and most students go like, ah! So what happened was all these classes built by computer science departments aimed at, college students at Princeton or whatever, or Johns Hopkins, they realized that those classes didn't start at a lower enough or basic enough level. So I basically became the de facto prerequisite to every technology course on all of Coursera, and the rest, of course, then is very much history. After the success of Programming for Everybody, I have since just built a series of beginning courses, whether it be Django for Everybody, Web Applications for Everybody, which is PHP and MySQL, or Database for Everybody, PostgreSQL. These are all classes that fit into the curriculum at the University of Michigan School of Information, and that I taught on campus. And so our goal is mostly to teach beginning programming classes. We're not really a computer science school. So as the years went by and I was assigned to teach various different beginning programming topics, then each one I just turned into a Coursera class, because I have a whole framework and infrastructure for building autograders, and every time I build a course, I kind of build it as a Coursera course, at least since 2012. And so, I get well over 1,000 students around the world, 1,400 in India alone, every single week that enroll in the course. And so I am feeling very successful I'm getting people started. But one of the more common questions that I get when I talk to students is, how do I get a job? And a lot of people can take one programming course that's really just a introduction to understanding programming, and they can get a job. Probably that was because the other skills that they're not getting a job because of their deep programming skills. They're getting a job because they're awesome people and they know enough to learn something in their programming, right? And so, they get a job and they didn't get hired to be a programmer, but they're going to become a programmer afterwards. And all I really did was I gave them the pieces that they needed to learn more stuff. And you'll see that as a recurring theme in this. And I get asked so many times, how do I get a job? And one time I looked at that and I'm like, well, how about if I change the question a little bit and ask a question about who would I hire as a software developer? And I have a number of people that I've known throughout my years. Most of them came through the Sakai project. They're some of the brightest and most brilliant programmers I've ever known. And if I was starting a company and with an unlimited budget, these are exactly the people that I would hire. Now, if I look at the inventory of all the people that I would desire to hire if I could afford them, a lot of them don't even have computer science degrees. They're not the most educated. They don't have PhDs in computer science, of course not. They're not the smartest people. They're not like geniuses. And let me define genius a little bit. So for me, genius is like, I've got the highest LeetCode score. LeetCode score is a almost athletic kind of programming that measures just the pure horsepower in the engine that's inside your head. And I think it's a terrible measure, because people who are the best at those kinds of sort of deep internal mind things, those are often the worst people to work with. And so that's what I mean by they're not brilliant. They're wonderful, they're talented, and a lot of these people gain their experience working on large, extremely complex projects, and they love working for people. So I'm like, okay, I kind of know what I don't want from a potential new hire. And then I start looking at, like, is my new hire a sum of just whatever, 35 or 40 different skills? Because I want them to work on my thing. And is my thing React, or is my thing Objective-C? Is it Swift? Is it Kotlin? What architect picked the weird set of technologies that is my company's stuff? Now, if it's my company, it's going to be really conservative technologies, but a lot of companies pick crazy stuff. And that makes it so that it's more boutique and cool, and if you're going to write it in Kotlin, then it better be cool, right? You can't just take an off-the-shelf COBOL program if you're going to write it in Kotlin. And so none of the people that I want to hire have the inventory of their current skills is not really what I care about. And so it's not what they know. It's not what they were taught in school, and it's not what they have gone to a boot camp and learned, or even taken a bunch of Coursera classes and learned. That doesn't automatically make you, having a whole bunch of Coursera certificates does not automatically make you a great programmer. And then I kind of get down to the following, and that is, it's not what they know. It's not how they were educated. The most important thing for someone that I want to hire and put in my organization and pay my hard-earned money to hire, it's how they learn. It's two aspects of how they learn. First, it's how fast they learn. So you take the people in my list of greatest software developers I know, and you literally can drop them. You can hire them as the CTO of your Chief Technology Officer of your organization, and they don't even need to know what technology you use. You hire them, and they'll be like, okay, what are we using here? You'll be like, oh, we're using Kotlin and MongoDB and Ruby on Rails and blah, some arcane set of things. And these people will say, okay, give me a couple weeks. And at the end of that couple weeks, and this is what I mean by quick, right? At the end of the couple weeks, not only will my best programmers know everything that they've been asked to know, they will potentially know it better than almost every single person on the team. And that's because they don't learn it as syntax. They learn it based on understanding. They learn it based on a deep, multidimensional, three-dimensional understanding of how computers work, how software works, how operating systems work, how runtime environments work, all of these things, how memory management works, how networks work. So you can't just write a line of code and go like, well, it looks like a good line of code and it passes a unit test. No. When you're writing powerful, sophisticated, rich, complex code, you need to be able to see all of the impacts. It's a very three-dimensional, abstract view of what you're seeing on the screen. So not only do they learn it deeply. They learn, is Kotlin, and I don't even know, is Kotlin a compiler or an interpreter? I don't know. But if you hired me to work on Kotlin within 4 weeks, I would know a lot about it, right? And I would study things that you might not even think. It's not just the programming languages, it's the libraries, it's the runtime, it's these things. I might write simple little pieces of code, and I'm like, what happens inside Kotlin if you do this, that, or the other thing? Not that I want to learn Kotlin. So let's just think about this from the point of view of designing a curriculum. And we can think of this as designing computer science curriculum. We can think of this as designing a Coursera curriculum. We can think of this as what kind of investment would we make in our current employees if we wanted to up their game. And so let's start with this. Let's start with this long list of all the possible things that you might go into a brand new job without much awareness. You'll walk into this brand new job and just pick from this list. Just pick 3 words off this list and that's your job. And the question becomes, if that's how the world works, that every job you take, there is 3 random things from this slide that are the things you got to know. I can't put you in college long enough to teach you every one of those things. And if I kept you in college for 10 years and then you had all these certificates, as soon as you go into the job market, there's going to be something else. So it's not sufficient to just gather all the certificates. It's fine to learn continuously, and everything you learn fills in gaps. So I'm not saying don't learn more things. What I'm saying is the quest is not to learn as many things as you can. I used to think that. I really used to think that if I learned all these things, then I could make the connections between all those things, and then I would know everything. So then I go through a different kind of an exercise, and that is, if I was going to build a curriculum, and underline the word I don't really trust computer science departments to build curriculums. I just don't. And that's because they have had curriculums for so long, and because of the demand in computer science, there's just no need to change curriculums. They don't need to improve their curriculum. They just need to kind of keep doing what they were doing 50 years ago. Because no matter how badly they do it, an infinite number of computer science students show up. They teach the same slide deck they taught 10 years ago, and away you go. So I'm talking about a brand new curriculum, not constrained by the sense of what a computer science degree is. If you were going to create the perfect path to the master programmer who can do anything and learn anything in 4 weeks, what would be in that curriculum? And so you can probably guess that the first thing in that curriculum is going to be Python. Oh, let me take that out. Boop. The first thing in that curriculum is going to be Python. Oh, I can move myself up into the upper left-hand corner, or I could go in the upper right-hand corner. There you go. So the perfect thing, I think, is the first thing is Python. Why? Well, Python is increasingly the foundation for so many things like large language models, like big data. It's just like it seems as soon as a new thing comes out, Python is sort of the first and most basic way to use it. And that's not saying that we'll use nothing but Python in large language models, but if you first see large language models, it's almost certain that you're going to see Python as the first language to kind of get you in. So Python is the welcome in, both for libraries and for programmers in general. So there's nothing wrong with learning Python. Learn it and learn it well. So the next thing that I did is I kind of pulled from this list and said, okay, what are the things that are really good from this list? And it'll come as no surprise, given that this talk is about C, that C is one of the things. Now, you might think that C is a good language to write code in, and I will tell you C is the worst language to write code in, absolute worst language to write code in. So I don't want to teach you C to teach you how to program in C. I want to teach you C so you understand everything. So Python followed by C, as we'll soon see, Python followed by C is to me the most powerful combination of programming languages to get you started down the path of understanding computation in general and understanding the complex, multi-dimensional world that is competent and high master programming. The other one I added here is SQL. It's really hard to imagine that anything worth doing doesn't sooner or later touch a database. And then architecture and assembly. And I don't mean architecture and assembly like so that you can be a complete hardware developer. I mean, I want you to know what a gate is and how an OR gate works, stuff like that. And so hardware is important to understand, but it's not important enough for you to be able to build hardware. I want you to be able to build hardware. I don't want you to be able to build hardware, but I want you to understand it. So if you look at these things, Python, C, architecture, assembly, and SQL, think of those as like 3 college credits. So that is about 12 college credits. You could think of it as 1 semester. It's kind of a long semester. You could also think of it as 10 hours a week for a year. And so there's a lot of ways you could take this 4-course curriculum. And then I thought, okay, given if these are the super foundation, are there other skills that we could build on top of it? And these things in these boxes are the classes that I want everybody to learn. Every single person, I think, needs to learn these things. Every single software developer needs to learn and master these 7 skills. And so at this next level, HTML. People think that you are born knowing HTML, and probably most of the people watching this do know HTML, but I'm just saying it's important. JavaScript is also important, because if you look at all the things above the line, you're like, okay, what things if you're going to learn Node or React or Angular, well, you need JavaScript. And so I'm not talking about a React class. I'm not talking about an Angular class. I'm talking about a foundational JavaScript that's just JavaScript. What's a browser? How does asynchronous stuff work in the browser? So that when you get to jQuery or React or Angular, you're like, I got a lot of basic knowledge. And at some level, we need another language beyond JavaScript and HTML. And I have chosen Java here, although you could probably put any number of other sort of higher level languages. These have to be memory safe, they have to be object oriented. And so certainly if you said, okay, I don't want to do Java, I want to do C#, I would not disagree with you. For me in my curriculum, I'm an open source guy, and so I just don't enjoy using the Microsoft stack, but a lot of people in business do. And so if you were to say, nah, let's not do Java, let's do C++ or C#. C++ is, there's some argument in the world as to whether C++ is a memory safe language or not, because the US White House came out with a kind of soft directive that said people should stop using memory unsafe languages. Means C is a memory unsafe language. C++, in most people's book, is not a memory safe language. Rust is a memory safe language, meaning that if you over-reference an array, you don't destroy it or introduce a bug. But C++ is arguing, including Baron Strostrup, the inventor of C++, is arguing that the latest versions of C++ have the possibility of being memory safe. I'm not sure that's a strong enough assurance. C++ has historically been a high performance, embedded kind of a situation, and it does a good job at that. And the notion of it being memory safe, maybe, I'm not sure that memory safe maybe is good enough to call it memory safe. But okay, be that as it may. This last language is probably needs to be taught in the context of some larger software development project. And so I talked to a company called KPIT in India that does C++ work for in-car software. And, you know, it's 15 years ago they started with C++ and they got all these C++ libraries. So in that place you're going to learn C++. So think of this last one, this Java, is almost like your bootstrap, your boot camp in your company. And so the Java one is a bit of an overlap between where you're going to work and what you're going to learn. But in that, it should talk about object orientation, it should talk about inheritance and stuff like that. So I look at this, then I see 21 credits, which is just about a year, and I look and I got some of these things already. I've got Python already, I got C already, and I got an SQL class already that are kind of roughly the shape of the 3 of the first 4. Now I've got Django for everybody and web applications for everybody that aren't in my list. They're kind of in the 3rd tier of things, but I got them, so they're there. And so what I'm trying to do is I'm trying to restructure my course offerings so that I have the foundations covered. And so the first class that I'm building is this class that I call C Programming for Everybody. And the text here that you can't see because it's the wrong color is looking at Python through the C lens and then looking at C through a Python lens. And so my goal in this C programming course, C Programming for Everybody, is I want to make it so that you know Python better when it's done. Right? It's not something where I want you to learn C. I want you to use C to understand how the computer is used to actually implement Python, right? Which is very different than I'm waiting to go write C code. I want you to know what is, I can move this down here now. Boop. I want you to understand Python, and I want you to understand C. I want you to understand kind of architecture. I want you to understand memory. I want you to understand dynamic memory. I want you to understand object-oriented programming. I want you to understand a whole ton of different things, right? And it's not like this is the course outline, because this is a terrible sounding outline, like understand interfaces, different implementations behind an abstraction. No, that's a learning objective. The whole idea is to build a course that is delightful, that exposes new ideas, that is fun to do, and when you're done, you kind of go like, oh yeah, I kind of understand the difference between an interface and an implementation. So don't look at this as the course outline. So let me give you just kind of a sample course outline from this course, C Programming for Everybody on Coursera. So here you go. It's a C class, right? But we're going to learn in the course 4, we learn how to do building of objects in C. So object-oriented programming, a historical perspective. Those of you who've taken my courses know that I love history and I love making these like fake chalkboard things about what inspired what, etc., etc. There's of course a play on the movie School of Rock where he has the picture of all the rock bands on the chalkboard. And so the historical perspective is like, we know about programming languages and we kind of have a history of programming languages, but object orientation as a pursuit kind of in a separate layer above for procedural languages, that's a separate thing that had its own history and its own inspiration and its own sort of experiments and its own language evolutions and all these things that happened in JavaScript and Python and C++ and Simula and Algol 68. These were all things that explored ways that we do object orientation, right? And so so that's the first thing, is like just a historical perspective. Like, this has been going on for a very long time. And it turns out that C and C++ are more coordinated than many think, because Bjorn Strostrup was hired at AT&T Bell Labs in New Jersey after he graduated from college, and worked actually in the same hallway as Brian Kernighan and Dennis Ritchie. So there was a lot of cross-pollination and influence between C and C++. And you can think of the evolution of C from 1978 to 1984, which when the second edition of the book was given, that was heavily influenced by the demands and thought and the object-oriented thinking that's in C++. Then we see Bjorn Strostrup, and then we see an interview with Bjorn Strostrup, the interview of the inventor of C++, and he tells us a lot about the magic of C++. We're in a C course now, right? But we're learning about C++. And then the comparing object-oriented approaches, I talk about JavaScript, I talk about Java, I talk about C++ and Python, and compare all those things to say, look, object orientation is a really powerful concept, and yes, each of these languages takes a little bit different approach to it, right? And so that is just a sample of one of the weeks of 4 classes in the C Programming for Everybody specialization. Now, this is based on a very special book to me. It's not a book that you can buy. If you take a look, this second edition of the C Programming Language, this is the book you can buy. And it is by Brian Kernighan and Dennis Ritchie, and it's the 1984 edition of the book, which still you can buy in print. And so this is the book that most of you bought and used when you took a C class, and lots of you have. I think you've taken C classes, you've just taken the wrong C class. So you took a C class that had a different understanding. Well, its goal was different. It thought it was just teaching you programming, and that's fine, because you do need to learn to program. It was a first programming class in a lot of curriculums. Or C++. If you do bad Java, C++. If you do kind of mediocre C++ and you don't really understand C++, it's a fine first programming language, except I think it's a bad one. I think Python is better. So the book that I use in this class is C Programming Language from 1978. It's a more raw book. It's not as polished and sophisticated as the 1984 edition. And what I like the most about it is the authors break the fourth wall when they are talking in this book, right? They will tell you why they did certain things in C, and they'll just explain it. And they'll say, like, well, we did this other thing and the bit alignment wasn't right, and so in the Interdata 732 we did this other thing, and that's why structures are the way they are. And in the 1984 book, they don't say that. They don't ever break the fourth wall. And so the other thing that's kind of going on here is 1978 is the moment where everything changed, right? Everything before this book, before the C programming language, every time that we would buy a new computer, you'd have to just go learn a new programming language, because different computers liked different programming languages. And, and so different hardware architectures the programming languages were well tuned to different hardware architectures. After C, we wrote in one language, and I'm talking about operating systems and low-level utilities. Python itself was written in C, and then now we can write in Python instead of writing in C. But portability across multiple computer hardware vendors and across multiple generations of computer vendors became possible because of C. And then we wrote more portable things on top of C than they were portable as well. And so in 1978, everything was changing, and you could think of this book, this C programming book in the 1978, was like the announcement of the summary of 15, 20 years of research into software portability. And so it is an important time in our world, and that's why I use the 1978 edition, because I'm focused on understanding the nature of computing, and in the 1978 edition they show the nature of computing. So it has it's an online textbook. I digitized it. I thought I was going to get in trouble with Pearson, but since then I have talked to Pearson, and they're pretty happy with it. There's auto-graded assignments. It's a browser-based compiler environment. Just like the Python class, I did not want to force you to install a C language, because it turns out that when you compile C, you can tell it to do all these, emulate different versions of it, and I'm making it emulate the earliest version of C. That's not necessarily the right version of C that you want to use, and so I didn't want to fight with all that. If you're going to look at my code samples, I wrote in the antique version of C, and so I make the compiler do the antique version of C. So the book is free and it's online and it's HTML. I wrote it, I digitized it and had it turned into Markdown. And that means that those with limited vision, that blind and low vision students can use HTML as the best way for them to read, pretty much, because then they can move, effortlessly around in the book and see all the information that they need to see. And so we made it highly accessible, and that's actually just our benefit, right? If you go to the book URL, there's a code, and the code is 42 to unlock it, because when I first did it, I didn't want Google to find it in case Pearson would find it, and then I would get in trouble, so I hid it behind a code. I think I don't have to hide it behind a code, but I still think it's fun to hide behind a code. So there's a Easter egg, which is the code that you get to redo this. It has a built-in C compiler. This C compiler is kind of weird in that it uses a server to compile it, but it doesn't use the server to run it. The danger in building autograders is if I use the server to run code that students write, then those students can try to escape my sandbox and harm my server, run it out of memory or crash it or change grades or delete files or whatever. And so the code doesn't actually run in the server, so I didn't have to build a padded cell to keep it safe. And so it just runs on your browser, and then the output comes back to the autograder, and the autograder looks at your output and decides if you got things right. So it's a pretty cool compilation environment. It's designed to handle hundreds of thousands of students pretty efficiently without too much server resources. Once I created the textbook online, I decided that I would also read the textbook. And so you can subscribe right now as a podcast to audio.ccforie.com. And you can just listen to the book if you find it interesting. I only did up to chapter 6 because chapters 7 and 8 get a little bit dense, and so that's not too much fun to read the pages and pages of code in chapters 7 and 8. This is available on Coursera, but it's also available for free for other teachers, for students who want to do review long after they took the course. I also want to make it free and publicly available because then search engines and increasingly large language models can look at this stuff, and you can just start asking questions, and maybe you'll find yourself to the front end of my YouTube videos. So I make sure that everything I do is also public, and it's also Creative Commons attribution, and so it's on my YouTube channel, the Dr. Chuck YouTube channel, and it has no ads, right? So there's stuff that shows up that YouTube puts up no matter what, but I have turned ads off on all this material. So if you are a teacher and you want to use this material, you get to use it for free. So another thing that I always put in all these courses is interviews. As I showed you, there's a lovely interview with Brian. There's 2 interviews with Brian Kernighan, and there's an interview with Bjorn Strostrup. And I am currently working on, and we'll add to the class soon, an interview that I did with Guido van Rossum, where I talked to Guido van Rossum about the approach to object orientation inside of Python. And what's cool is that I wrote at the end of the last class, you're building a string class, a list class, and a dictionary class. Remember, I say look at Python through the lens of C, and look at C through the lens of Python. So you build these things, and I built them based on chapter 6, wherever that is. Chapter 6, that's chapter 8. I built them based on chapter 6 of this book. Right, so, chapter 6 of this Kernighan and Ritchie book. So I asked Guido, I said, Guido, did you use chapter 6 of the Kernighan and Ritchie book? And he said, no. I said, did you make linked lists? He said, no. I said, did you make hash maps with linked lists coming off of buckets? And these are all the ways that we computer science programmers think of. I've been using Python for years, and I just assumed that list meant linked list, and I assumed dictionary was hash. Hash maps the way we see them in Kernighan and Ritchie, because we all learned it from this book or some derivative of this book, right? And he said, nope. He said, I found a algorithm in a different book, and that book that he found the algorithm is a book called, there you go, it's called Sorting and Searching, The Art of Computer Programming by Don Knuth. And this was an earlier book that had all the knowledge in it, and he used a technique from this book called open hashing, which is way, 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 way deep in the book. It's hard to find the part that Guido found to build dictionaries and lists, but he used the concepts in a much earlier book than Kernighan and Ritchie. Although he knew Kernighan and Ritchie, the book, and he learned from that book. He actually had known C++. And so the bottom line is that I'm going to add an epilogue to the course, which is basically me and Guido and myself reflecting on the actual implementations, which are different than the implementations that I did in the course. Because I did the implementations in the course the way that I did the implementations in the course the way I would have done them if I'd read the C programming for the C book in Kernighan and Ritchie. And that's what I did in the course, because I'm a computer scientist. We're taught this certain way of doing things, and I did it those ways. And Guido did them differently, because he's not really a formally trained computer scientist. He's not a computer science researcher. He was solving engineering problems, and it was not his first time building a programming language. It was like his second or third time, and so he had some real strong opinions about the right way to do it. And so what this epilogue will do is it will be me and Guido talking about how I did it based on Kernighan and Ritchie's book, and then how he did it based on his own experience. So with all that leads to the C Programming for Everybody, which to me is a course that is unprecedented. It is unlike any other programming course on the planet, as far as I'm concerned. It is a course that is to teach you Python. C programming to get better at Python, and then Python programming to get better at C, so that when you're writing Python code, you're seeing deeply into things that are happening. So then I've got more classes that I want to build, and so the next class after this will be a computer architecture class, and I want to keep that as simple as I possibly can. These are the learning objectives. They're not exactly the course outline. And so I want people to know what electronic computer is, what's a gate, what's inside of a chip, how do CPUs work, machine language assembler, compiler, runtime environments. And so this sounds like a hard course, but I'm going to make it as easy as I possibly can and fun as I possibly can, and just make it so that it's as engaging and that I can get to those learning objectives without sort of beating the students up too hard. I want to make it for everybody, hardware, computer architecture for everybody. And in doing that, I want to, really figure things out. So that is the end of my slides. The real takeaway from this is it's not about in your education learning everything. Your education really needs to be about preparing to learn everything. We don't want you to try to fill your head up with infinite amounts of knowledge and try to take 30 or 40 different technologies and put them in your brain. When I look at a resume of somebody who's 21 years old and they've got 35 different keywords in there, like Perl and Python and Kotlin and whatever, I'm like, okay, you're 22 years old. How well do you know any of those things? And I'm not saying people shouldn't have a good resume with lots of things in it. I'm just saying that we don't gain much information by you just listing 40 things that you have touched in your short educational career. So with that, I am going to turn off my slides. I have not been watching the chat. Let's end the slideshow here. And let me bring the chat up, and we can start with some live questions and answers. Come on, Chuck, find where that chat is at. There is the chat. There is me talking. Let me prop the chat out. Pop out chat. There we go. I'm going to move my screens around, and then I'll share my screen here. And I'll make the chat bigger. Boom, boom, boom. Okay. Okay, so here we go. Okay, so now I'm going to put the chat on. Boom. So there is the chat, I think. And we'll do this. Will put me over here, or maybe put me over there. My face is looking the wrong way. Okay, so here we go. Let's go through. Hello, everybody. Let's see. Let's go through some of the questions. When will the hardware computer architecture course be available? I hope to have it ready by next May, so I can go back to India and introduce that course to a different set of students in India in next March, actually. We'll see. It might be 2 years. I got other things I've got to do, and so I can't put all my energy into the hardware course. So I've started doing, Pranav says, I've started doing your C programming course. Can you tell me the right way to go through the course? Should I read the book and go through the lectures and then try the assignments? Absolutely. What you'll find when you start looking at the C programming for everybody course, in the beginning, mostly what you want to do is read the book and take notes in the book. And I have these little mini lectures that kind of contextualize the book. So if you look at chapter 1 in the Kernighan and Ritchie book, you're supposed to read chapter 1 because I think it's well written. I think you can understand it. And so I have a little lecture that talks about chapter 1, but it doesn't repeat what's in chapter 1. So in chapters 1, 2, 3, and probably 4, I really lean heavily on the textbook. So you could watch my little, you look at the length of the videos and you'll see that the video length is short. Let's move this here. You'll see that the video length is short, and my video length is short, and then the book is longer because the book sometimes is like an hour to read, and so it's. But then what happens is once I get to like chapter 5 and chapter 6 for sure, the book doesn't even do 7 and 8 because they're too complex. But in chapter 6, the book gets hard to understand. And this is the problem with most beginning C classes, is if they stop before chapter 6 of this book, then they do pretty well. And so if they stop before chapter 6 of the book, they do okay because they've just taught basic programming. And so the teacher just kind of teaches you chapter 5, and then they teach you chapter 6, and all of a sudden your head explodes because the chapter 6 is a completely different topic than chapter 5. There's a little bit of stuff going on in chapter 5, but certainly chapters 1 through 4 are just basic programming, just basic syntax. It's kind of like looping and variables and this, that, and the other thing. And then chapter 5 and chapter 6. And so if you're in the course, certainly chapters 1 through 4, mostly I ask you to read the textbook. I just want you to read the textbook. I don't want to restate the textbook. I think this textbook is really good. And so chapters 1. But then chapter 6, the textbook is too hard. The textbook is way too hard. If I can't just say, go read the textbook and understand it. So what happens is there just was not enough explanation. To me, if we could rewrite this book, which I don't want to because it's an antique, chapter 6 would be about 4 or 5 chapters. And so you'll see that chapter 6 spreads across a course and a half. It's all chapter 6. And so what you'll see is that as I feel like the book is starting to let you down in terms of the kind of detail it gives you in chapters 5 and 6, I give more lectures. My lectures get longer and longer and longer, and the book is like, yeah, you can go read the book if you want, and you should read the book. So, Pranav, the whole idea of read the book in the first few, and then you should read the book totally, but the key thing is in 1 through 4, you really read for understanding in the book, and you should have no problem understanding it. But you will notice that there's a kind of a shift 2/3 of the way through the course where I just don't like what the book is not good enough in the last part of the course, and so I give you a lot more detail to support what's in the book. So you'll see, one subsection of one chapter, and then you'll see me talk for 45 minutes about that. So yeah. Okay, so let's see. I got a comment from Batul that says, I made it to the capstone and now I'm stuck. I'm curious as to why you're stuck. One of the problems that I find really, really frustrating is that Coursera has I don't know if this is your situation or not, so don't take it personally, but I get a lot of email from people who get caught because they upload someone else's assignment. And then because the teaching assistants know, so if you're taking Python for Everybody, don't upload someone else's assignment, especially in the peer graded things, because they'll catch you. So a lot of people might be like trying to get through the class in a hurry, go into somebody else's guide, and they say, just upload this file. And the answer is you'll get caught, and then you won't be able to finish the course. And I do wish that Coursera might come up with a different policy, but I don't jump on top of Coursera and tell them to change their policy. I wish they would do something like maybe after a month or so give you another shot or something. But people do get stuck in the capstone, which I don't like. I don't like when people just are following a guide and doing a class and getting then caught. So I feel bad. I don't have a good plan for that. So don't upload other people's stuff. Okay, let's see. Dr. Chuck doesn't age. Yeah, luckily I got gray hair. Before I started, my hair became gray before I started, and so yeah, it stayed gray. I don't change my beard or nothing. Let's see. Hello. Welcome from Buenos Aires, Argentina. Paid for intro to programming, learned it from Dr. Chuck for free. David, good point. Every one of my courses, now and in the future, there will always be a free version of them. You can go to online.drchuck.com and you can see all my courses. If you go to those pages, they say, hey, go take it on Coursera. Pay and get a certificate. I make money. That's my, hey, like and subscribe, right? That's my equivalent. It's like, oh, hey, take it on Coursera. And so that's my way of raising money, and so that's okay. But I am not so stuck on raising money that I don't give it to you for free, because I know that there are an infinite number of complexities in people's economic situations around the world, and so the simple thing to do is to always give it away for free. And that includes the auto graders, that includes the online compilers, that includes everything. So you can go to ccfree.com and you can get the exact same experience. Perhaps with a little less support than we get on Coursera, but the exact same experience. And so making it available for free is essential. And the other thing that's essential about making it available for free is you'll pay for Coursera, and you pay for it by the month or whatever you do. And then you'll be like, okay, I took a few courses. I'm going to turn off my Coursera subscription because I paid enough. Or you graduate from college and you don't have access to Coursera anymore, right? You took it while you're in college, because a lot of colleges just license the whole Coursera catalog and give them to their students so they can add stuff to their resumes. And then you graduate and you can't have the Coursera stuff anymore. Well, for me, I'm like, I don't want to leave you just because you graduated from college. I want you to be able to come back and A, learn more stuff, and B, review stuff that you already know. And so for me, online.dr-chuck.com is essential, and it is literally the first place that I put things. The second place that I put things is on Coursera. Okay, Branislav, why do you think Java is necessary in addition to Python? Okay, so, and there's another comment. There's another comment. Where did that other comment go? Who was it? Rupa. She said, no, it wasn't Rupa. Did Rupa have another one? Someone said, I'm having trouble with Java because it's too much memory. Okay, well, let me just answer both of those questions about Java. So the first question was, why Java? Once I know Python. The second question was like, wow, Java's difficult. It takes a lot of memory. So I am very committed to teaching the basics with as little required infrastructure on your computer. You can take a C class with almost nothing on your computer. You can take a Python class with nothing on your computer. You can take although in the second part of Python you do have to have something on your computer. The Postgres, you don't need too much on your computer. You need a little Python and a Postgres client. And the hardware architecture will be kind of nothing on your computer. It'll all be online. The problem is at some point, if you're going to be a professional, you can't just click in a browser to do everything, right? I try to make it as easy as possible for people to learn. And so I make it so that everybody can click in a browser and not have to install Python on their laptop to be a beginner. But at some point in a professional world, you're going to need to use something that's big, like Java. And it may not be Java, but by the time it's done, as a master programmer, you've got to use your laptop. You've got to use the computer that's sitting in front of you. You just can't go make big salary and be a leader and not be able to do stuff on your laptop. And so there's where Java is. And so what Java is it's the first language that I'm not teaching you kind of in the abstract. I'm going to teach Java that's embedded. And the key to Java is then you're going to have to, if I'm telling you you're going to be a master programmer, right? And you're telling me, well, I can't even run a thing on my laptop. Well, you might need a better laptop before you become a master programmer. And so Java is a way to kind of test if you really can have the kind of local infrastructure that you need to be a master programmer, right? My laptop here is a 32 gig Apple M1, and it's a professional laptop. And so at some point, you need to get to a professional state. And so if you think about the master programmer, by the time you're taking Java, if you're following my curriculum, you'll take 7 classes. By then, if you're going to be a master programmer, you may need to buy a laptop with, at least 16, if not 32 gig of RAM, terabyte of SSD. It's got to be a beefy laptop. And we're going to test you on that, right? We're going to make it harder in the Java class. And the other thing about a Java class is that Java it's got affordances in the language, like annotations and streams, and there's complex advanced stuff in that language. And I spend so much of my time in these languages showing you simple. And before I let you out of my site with the master programmer stamp, I want you to have seen complex stuff. I want you to have seen large code bases and how Java can be used to manage the large code bases. And that's why I said C# would be okay, but not just as a programming language. C# has got to be like an environment, right? You're going to install it, you're going to run it, you're going to look at large code bases. I don't have any large C++ or C# code bases, but in Java I do have large code base, right? And that's Sakai. And I want to show people a large code base. So the Java class is not just Java, it's Java and large code base and powerful infrastructure and all kinds of grown-up stuff like GitHub and bug tracking and all those things. And so the Java course is like the capstone in my world, and it is a course of a different kind. And I imagine that in my curriculum, there could be multiple capstone courses. And I also, the other thing, if you look at my classes, I am absolutely expecting, let me show you something here. Let me see if I can get this just to pop up on the screen the right way. Boom. Let me show you this. So here's kind of like the ultimate. Is this going to work? It is going to work. Okay. Yeah. So if you look at this, right, Python, C, Assembly, Architecture, SQL, those are kind of your beginning classes that are, Python is probably the only class that's a prerequisite, although Architecture and Assembly could go first. HTML is not that hard. JavaScript, not that hard. But Java is like the capstone. So you can kind of see these things in order, and Java is the last thing, meaning that Java is the first of the complex things that I want to teach you. Okay? So Java is the... So you could think of Java is not the last. Java is an overlap between here's your training and here's your work. And your work can be any of those things, right? It can be 35 different things. So that's kind of the capstone. You could almost call it an internship. You could almost call it like a pre-work boot camp. And so it's like that's why I'm kind of obsessed about Java, is that it's the first thing that you. So Java is the first really, like, we're going to slow down. You know everything. You know what an if statement is. You know what object orientation is. But now we are going to teach you a big environment, a professional grade environment. Okay. Let's see. Let's take a look again at the chat, see what we got. How do we get out of tutorial hell? Should we create 1 to 3 projects per programming language to build an online portfolio to leverage when we're applying for jobs? Terrell, Tony. Yeah, that's a good question. And someone else said, Rupa said, I've audited Python in 2017. Now I'm an open source, though on a different, contribute on a different tech stack. Grateful for your course helping me restarting program. Okay. So it's a time for a bit of a rant. Let me get a cup of coffee so that I can rant. So getting a job is difficult. And Prith said, what should I do? How many keywords should I put in my resume? And so just because I think something is a good idea or a bad idea doesn't mean you shouldn't do it, right? So you might say, oh, Dr. Chuck says he's not happy when he sees a 22-year-old person's resume with 40 keywords in it, right? And Prith said something like, well, if there's a software that's doing keyword checking, I got to put 40 keywords in. I can't disagree, right? Let me tell you another thing that I will never hire a person from. I will never, ever hire a person. If you put your LeetCode score in your resume just dropped at least a halfway down my stack. And so I hate LeetCode, and I hate companies that use LeetCode in their hiring. I hate LeetCode. I hate companies that use LeetCode in hiring. My dislike of it does not mean that companies don't use LeetCode. So what do? Do you do LeetCode? Sadly, if you're a computer science student, you kind of have to do LeetCode because it's the game that everyone plays. But don't talk to me in an interview and say, look at my LeetCode score. I'm like, well, you know what? And here's what I don't like about people with high LeetCode scores. LeetCode dehumanizes you. LeetCode takes all that is you, which is a rich, creative, wonderful, friendly, helpful person, and it reduces you to a number. Not only does it reduce you to a number, it puts you in a situation where you get no credit for helping other people. You only get credit. Your best strategy is for other people to fail. And so you're sitting there on LeetCode, and if your best strategy in LeetCode is for everyone else to fail and for you to succeed, I don't want you working for me. If that's what you've been trained. LeetCode trains you to be some kind of a thing. It does not train you to be a team player. And And so then, okay, Chuck, you just dunked on Leet Code, and I agree with you, but I'm stuck because where I'm going, all the companies look at Leet Code, so I got to do it anyways. I'm like, yes, you do. You're a computer science student. We're not. I have revolutionary ideas, but it's a quiet, slow revolution, right? So you got to do it. You got to do Leet Code if that's where you're going. If you're a computer scientist and that's where you're going. But let me tell you how I hire people. I told you I don't use Leet Code. I hire people by looking at their GitHub contributions, and in particular open source contributions. And so if I have, and I often do, have 30 resumes, and all of them look good. Their cover letters look good, their resumes look good. They all have a similar education, right? And they did well in their education. So these are good people. I probably could hire any of them. I could probably just throw a dart at the wall and pick anybody. So the way I do, the dart that I use is GitHub. So if you send me a resume and you don't have a GitHub URL, that tells me something. And some people think, oh, well, I'll just do a portfolio, right? So I'll tell you why I don't like portfolios. And I'm not saying portfolios are a bad idea. Like my son is in advertising, and his portfolio is like, I made this campaign. I made this graphic. Here's a thing I did. Here's a spreadsheet of this campaign plan. That is a good portfolio. But if you have a thing in your portfolio, and you're 22 years old, and you have 25 projects in your portfolio ranging from mobile to React to big data to large language models, and you just put a bunch of screenshots in your portfolio and you got 20 of them, I'm like, well, what was your role in the LLM project that you worked on? What was your role? And again, if you worked on those projects, you shouldn't lie about them and say you didn't work on them. But the problem is I can't figure out what your actual contribution is by just looking at a portfolio with a large number of projects with a large number of screenshots. And so this, for me, is where GitHub wins. And I think if you have GitHub, I can look at what your contribution was. Not only can I look at what your contribution was, I can look at how you talked to people, especially if you're contributing to a project that you are not in charge of, right? It's not just, I wrote this thing, I did a tutorial, and here's my big data tutorial, and here's my bar chart of this thing, which visualizes a well-known data set, and here's my thing. No, working with people is much harder than just going through a tutorial. And so for me, I want the future to be GitHub. And I think the future is open source projects, because the nice thing about open source projects is you get to own your green squares in open source projects. If you work for a company, they'll take you under non-disclosure immediately. So all the cool stuff that you do on your internship, you can't show anybody. But if you do your internship in open source, and that's a long-term goal of mine, is get to the point where I have a scalable way of doing open source internships, including open source paid internships. But that's way out. I got to be able to make master programmers. And then I got to go raise some funds. Or maybe I can convince, I've been talking to Coursera about this, and we've been talking about, let's just imagine that you've taken 7 Coursera specializations and they've made a certain amount of money off of you, and you're going to take that 8th one, which is like the capstone. Would it be possible to give you some of your money back in the 8th one, right? And so I do think that when you're doing this kind of work, it'd be nice for you to be paid for that. So my hope and my goal is to lay a groundwork where instead of Leet Code, people can spend a year in college, perhaps their last year in college, working on open source and building a wonderful portfolio in GitHub. And then you imagine a situation where you're doing a joint internship between an open source project and your college professor, and your college professor sort of knows about the open source project and guides you through it, and guides you so you get like green square after green square after green square after green square, and you're learning things at the same time. So, oh well. Okay, let's go back to the chat. See what else we got here. Oh yeah. So I'll NHV 57. I'll get to that one. Let me see if there's a shorter one. Yeah, I got the same question about the AI in India. It's so fun. So Terrell, that's kind of it. Create 1 to 3 programming projects per language. I would find my way, just like Rupa was talking about earlier. I would find my way into open source, and don't worry if your contribution seems pointless for a while. That's part of being a master programmer, is being an apprentice programmer. So Natalie asks, a new version of Python for everybody was just released last fall. I finished the specialization 2 years ago. Are parts of the updated courses that you would recommend to cover your new material? So Natalie, don't worry about it. So there's 3 versions of the course. The first version was Python 2. The second version was Python 3, which was a big deal, obviously. Unicode in the second version, but you took it, I believe, since 2017. If you didn't take the Python 3 and the Unicode one, that's a lot of stuff. But then the most recent update, which was 2024, the only thing I really changed in 2024 was dictionaries, because between Python 3.6 and Python 3.7, dictionaries became ordered. Now they're not sorted; they're ordered by insert. And in my Guido van Rossum interview, I was like, "What happened there?" And so I don't know if it'll make it into the final cut, but he talked about how he was using this technique from the book about open hashing, and they realized that they could maintain insert order. Long story. It has to do with the fact that the way they do lists is arrays of pointers, and then the dictionaries they realized that if they switched the dictionary from being a hash map, an array of hashed things in hashed order, which allows them to jump in the middle, they made it so that in effect a dictionary was a list, and then there was a separate index that could bounce into the middle of the list, and then do sort of lookups. They realized that a dictionary was just, this is pretty recently that they realized that a dictionary probably would be best built on top of a Python list at the low level in the implementation details. And so the 2024 change, you would be hard pressed. You'd have to watch the whole course carefully, which of course we did. But every time I say, hey, this dictionary, look how out of order it is. Well, it's not out of order. And so I look dumb if you know Python 3.8 versus Python 3.6, and I'm talking about Python 3.6, and you're looking at 3.8, and you look at the printout, you're like, it's slightly different. So all we did in 2024 was find all the places that I mentioned order and not order and all that stuff, and we took it out. So the bottom line is the 2024 update, don't worry about it. It can be summarized as dictionaries stay in insert order. Yay! That's it. So, but if you don't know Python 3 and you don't know Unicode, you need to watch that. Because to me, Python 3, the biggest thing in Python 3, other than just the syntax of print and the division, is Unicode. Unicode is so beautiful. And Python 3 does such a beautiful job of Unicode. It sort of did, Python 2 did Unicode badly, and it made things worse and uglier, but the Unicode and UTF-8 support in Python 3 is lovely. And any programmer should understand UTF-8 and Unicode because, ASCII is just for United States and like Northern Europe, basically. And Unicode is for everybody. And Unicode and UTF-8 is really, Unicode is just kind of we have really 32-bit characters. But UTF is a packing of those 32-bit characters that overlaps ASCII perfectly. And it took a while to figure out the right way to really do international non-Latin characters well. That was like a 15-year quest in its own. And then UTF-8 just finally, among all the competing ideas, UTF-8 came out, and people are like, "Oh, it's so perfect." And so UTF-8 is a perfect answer. So again, if you don't know UTF-8 and you don't know the .encode and you don't know the .decode in Python, then you should go take a look. And you can actually just go to www.python. Let me see if I can. Let me show you that. Let me bring up a browser here. Let me bring up a browser. I don't know if this is your question or not, but you don't have to go back to Coursera. So you go to Python for Everybody. Let's see, where are we at? I think I do that in network programming. No. Web services. Where do I talk about UTF-8? Oh, I know. I know where I talk about it. It's actually really early. Strings. Hang on. Where in my class is UTF-8? Oh, I can't. Somewhere in there is UTF-8. Dang it, I can't seem to find it. I thought it was in strings. Is it in files? Let's try files. I'm looking through all my PowerPoints here, like, where in the heck did I talk about UTF-8? It's not there. It's not in files. It wouldn't be in lists, wouldn't be in dictionaries. Tuples. I thought it was in networks. Oh, characters ASCII in Unicode. There you go. There you go. So characters ASCII in Unicode right here. That's the yummy bit. I love this lecture. I'll paste this into the chat. Yeah, right there we go. I'll paste that one in the chat. Okay, so that is the Unicode lecture. And if you're coming from Python 2, if you just learned Python 2, I think Unicode is the most beautiful part of Python 3. So let's see. Okay. Okay, let me answer Augustine here. Come on. Oh, there we go. So Augustine, I'm having trouble. You're having trouble grasping the concepts of programming. So I'll quote a quote from the movie Ready Player One, and that is, sometimes to go forward you need to go backwards. Those who know Ready Player One know that quote. And so the key thing is, and this is a problem that we have in general in educating people about programming, and that is that we want to put a schedule on you, and that's a uniquely college thing, and that is that you're paying me for 15 weeks and you're supposed to know programming at the end, and so I have to push you so far and so fast so that you know programming at the end. And the problem with that strategy is, at the beginning of a 15-week programming class, maybe 90% of the people can make it through that difficult, that level of instruction that it'll get you to where you need to be at the end of the 15 weeks. The problem is, for the 10%, it's the worst possible experience because you need more time. I don't think there's anybody that can't learn to program. I think there are people that need a lot more time to learn programming. And so Augustine, I would say that the right thing for you to do is to go back to the beginning, or go back a couple of chapters. If you're stuck in my Python class on chapter 6, go back to chapter 4 and do it again, because the key thing is mastery. Let me tell you a little story about my family. I'm in a family of 4, my wife, my son, and my daughter, and I'm the only one who was good at math in that whole family. And so everyone in my family at some point in their life needed to get a B+ or higher in calculus to go to college the way they wanted to go to college. And so I looked at all of them and I asked them, what do you know? And it turned out that they didn't even know fractions, like a least common denominator, like just add, just anybody here can say, can you add 1/3 plus 1/2 and tell me what it is? And I know that 1/3 plus 1/2 is 5/6, right? But I also know what the least common denominator of adding 1/3 and 1/2 is, and the least common denominator is 6. And then you convert the 1/3 and 1/2 to least common denominator. One of my most popular lectures on all of YouTube is my least common denominator lecture. So maybe I'll paste that in. Let me see if I can find least common denominator. Chuck Severance, least common denominator. Yeah, how many views has that one got? 311,000 views in least common denominator. There you go. Okay, so I told each of my family members that if they didn't know least common denominator, they had to go back and find a class that taught basic math. And there are classes at colleges that take basic math. And I said, look, you have got to take each of those classes until you get an A in the class. You can't just take the basic math class and get a C- in it and think that you're done, because it's about mastery, and that's where the master programmer and programming mastery come in. And so what I told him is, I said, you have to take basic math until you get an A. Then you have to take geometry until you get an A. Then you have to take algebra until you get an A. And then you have to take trigonometry until you get an A. And then you can take calculus. And I guarantee you, if you do what I say, and you take all those classes and get an A in all of them, that you will get an A in calculus, or at least a B+ in calculus. And they took my advice. Every one of them had the exact same, of the 3 people that I gave that advice to, every one of them had the exact same pattern of repeat classes. And every one of them got a B+ or better in calculus at the end of what I told them. And what I told them was, don't leave a topic until you master the topic. Don't be in a hurry. Just because we in college tell you to be in a hurry, that's for certain well-prepared young people who can handle it. That's not everybody. Everybody takes a little longer to figure things out. I know, because I don't learn as fast as I once did, and every once in a while I get stuck on something. So this is what happened in my family, right? So everybody in my family started at basic math, which include least common denominator. Everybody took it, did not do well in least common denominator class, and then they took it again, and they got an A in it. And then they went through every single class after that and never repeated another class. And so that teaches you that the foundations of anything are far more important than the pace with which you go through. And that mastery is way more important than completion. And so for those of you who are having trouble, don't push yourself farther. Go back to the beginning until you are so bored of watching chapter 1, 2, and 3 of my courses. You're like, of course, it's easy. What the heck? Because here's the thing. When something goes from difficult, and programming is easy. For those of you who are struggling, programming is easy. Learning programming can take a while, but once you know it, it's easy. And so you've got to just trust the fact that if you're having trouble, it's because you haven't learned it enough yet. And you need to go back and relearn it over and over again. You can find all of my stuff at the courses at. Let me switch to this. If you want to know all the courses that I teach, just go to, where did that go? What happened there? Come back. Is that here? Yeah, you go to online.drchuck.com. And you can see all the courses. Yeah, Augustine, I'm in college, try not to be in a hurry. No, what you want to do, college just assumes that you're smarter than you are. So you need to learn some of the stuff like over the summer and get good at it. And then when you go to college, you can meet their pace. And that's the sad part, right? So there's my online.drchuck.com, which is, as the hardware course starts to emerge, it'll show up there first. That's where you'll go. Hey, War Wheels, fractions scare you, but you got a college degree now, so you never have to learn fractions again. But you can watch You can watch the least common denominator, which I'm sure you did watch. You were one of the 311,000 viewers that watched it back in the day. I think I might have done that for you. Okay. Yeah, so, okay, it's time to hit a couple that I've been waiting for. Where was it? Somebody is talking about artificial intelligence. Who was it? Artificial intelligence. Come on. And then there's AI. Yeah, Natalie, I do agree that web design for everybody is a good Professor Van Lent. So far, that's a good question, Natalie. So Natalie's question is, does web design for everybody show up in my, I should add Colleen's course. Mathematical component, pah! When's the last time any decent programmer did math at all? So one of the things that's kind of weird about this whole curriculum is that it's all me, which is kind of weird. And the reason it's all me is that, and I just got an email from a guy from Singapore that wants to collaborate. He's like, I want to teach JavaScript at the beginning, and I want to do this, and I want to do that, right? I'll get back to AI in a bit. And the problem is that too many people are stuck in the ways of computer science, and their opinions are shaded by the current computer science curriculum. And so they can't give up on trying to satisfy the curriculum committee of a computer science department. I do not satisfy the curriculum committee. I tell them to go to somewhere else. I don't care what they think. I don't care if they think that an operating system class with LIFO and FIFO queues and Carnot maps and Moore and Mealy machines, I don't care if they think those are important. I just don't care. And I could be wrong, but I don't think I am. I think they're wrong. I think computer science has been phoning it in for 40 years and teaching mostly crap. The mathematics, AC says I find mathematics missing. No, it's because mathematics is garbage. I'm not saying it's complete garbage, but it's mostly garbage. At my university, you take 4 math classes. When I went through, I took 4 math classes. I took differential equations. Differential equations are wonderful for electrical engineers and mechanical engineers, and they're terrible for computer scientists. So I'll tell you why it is that computer science requires math. And it's not because computer science requires math. Computer science curriculums require math because they want you to not come into their program because they have too many people. So they use math as a filter because they figure if you can figure out math, it's easier to teach you. And that's what math is. It's to beat you up, and if you make it through, fine, now I'll let you in computer science. But if you can't handle this useless math, like semigroups and differential equations. So math is a game that they're playing with you, okay? And so, yeah. And so I am just going to avoid the math. I mean, I don't even think that you need least common denominators to be a good programmer. Math is meant to make you cry, yeah. So let's get to the elephant in the room. Let's talk about artificial intelligence. So you can, hey Brenny, can you find me the David Bombal lecture where I talked about artificial intelligence, the recent one, and see if you can put it in the chat. So I was on a chat. I came back from India, and when I was in India, I got asked the question over and over and over again about AI. Yeah, and the form of the question is that the CEO of NVIDIA just said that programming is obsolete because of AI. And I just wanted to go find the CEO of NVIDIA at that point and just grab him and shake him for a while. Just like, you are an idiot. Why don't you just shut up? Why don't you just shut up? Because what is AI? AI is the next evolution of natural language processing. 10 years ago, natural language processing was trying to read us on Twitter and decide if we're happy or sad. That was kind of the thing they did over and over and over again. And it was really cool work, and it was really great research. Large language models are amazing. I mean, one of my great weaknesses is I'm a really terrible writer. I'm a quick writer, but I'm a bad writer. And when I put my writing in artificial intelligence, I would beg people to help me rewrite my stuff so it sounded smooth and calm and not freaking out and loud and shouty. Because I'm a kind of a shouty writer. Because I'm so sure of myself and I'm so cocky that it comes off in my writing how cocky I am. And I can tell the large language models to take my writing and make it less cocky, and it does, and it's so beautiful. And I do this by finding friends who are good writers, and they just rewrite my stuff, and now AI can be my friend and rewrite it. And the large language models are so good at language, and they're pretty good at programming language, right? But the problem is that the people who are telling you that AI is great and no one needs to learn to program, the ones that are actually good at it are really good programmers. And so I was standing in a copy room 2 weeks ago with one of the smartest programmers I know. His name's Michael. And we were debating, because I was making copies. And we were debating whether or not AI was like transformative. And he was taking the case that AI was transformative. And I was saying it's not. I'm saying AI is a great tool. I love it. I'm going to use it. I'm going to use the heck out of it. And what he would do is he would try as evidence to tell me how great AI was he would tell me the things he's doing in his teaching. And I'm going to get this wrong because he's smarter than I am, but this is roughly what he said he did. Because I was Xeroxing an exam, and so I was talking about my cool exam, and he was talking about his cool exam, right? And he's like, yeah, I made an exam, and I had AI make the exam for me. I put a bunch of stuff in and I had AI make the exam. And then what I did was I had the students answer the exam, and then I took the answers to the exam and I put the answers into AI. And then I had another exam get generated about the answers that they had to this exam, and then I made the whole thing auto-graded with a QR code. And he's like, see how great AI is? And I'm like, no. AI is not great. You, Michael, you are great. You're one of the brightest programmers I've ever known. So in your hands, you make AI great. AI was not great. It was just sitting there. There's no way AI could have done what you did. Michael took AI by the hand and walked AI through a brilliant solution to an amazing problem, and he got an amazing solution, but AI didn't do it. Michael did it. And so when they say that you should not learn to program, that's wrong. It's more important that you need to program. And it's more important that you become a great programmer, a master programmer. Because if you're a master programmer, you can see into the heart and mind of AI, and you can lead AI in the right direction. If you're like, I don't know nothing, I just want a program to make me $1 million, but I just want to be rich and I don't want to learn anything, AI make me $1 million. Well, it ain't going to do that. Somewhere in between you writing all the code and AI make me $1 million is the reality. And if you aren't bringing anything to the AI conversation, meaning I don't know nothing, I just know what I want, well, you brought nothing to the AI conversation. Whoa, come back. Come on, stream. There we go. We're still going. If you have brought nothing to the AI conversation, if you don't know anything about computers, then you cannot help AI. So if you think about sort of, and so I'm not anti-AI, right? The only thing that I'm anti is don't learn to program because AI exists. And frankly, quit learning React. Don't take a frickin' React class. You don't need React because AI will help you learn React. If you understand computers and you understand software and you understand how it all fits together, right? Then you're going to use AI so well that you're going to be valuable. And going to a React boot camp or a Ruby on Rails boot camp is going to be freaking worthless. So you go pay $20,000, get a Ruby boot camp. I'm going to get you a job. And the answer is Because if you're a good programmer, you can learn Ruby from AI in 2 weeks. And you can use it for the rest of your career. So that silly little details, right? The silly little details that you need to know about Ruby, you don't need to memorize them anymore. But solving problems and taking a multi-step path to a solution to a problem, AI can do it. Let me show you a couple of pictures. Where am I going to find those? Let me find those pictures. Oh, here we go. They're right there. Okay, so let me share my screen here. Boop. So my son, he loves AI and he loves Dungeons and Dragons. And so, he talks about how great AI is. And so I asked AI 2 questions. I asked AI to give me a level 5 mage in a forest where it's raining and foggy, and I want the mage to have a red hat. And that's Night Kitchen. And AI did a really good job, right? That sure looks like a level 5 mage to me. I don't even know what a level 5 mage looks like, but I'm impressed at the detail. I'm extra impressed when I notice that the trees aren't actually in the dirt. They're kind of in the air and the roots come out of the trees and then they go in the dirt. I don't quite know why the trees aren't in the dirt, but maybe that's just kind of like cool, extra cool, because the mage isn't in the real world. The mage is in trees that aren't actually in the dirt. They just kind of grow in the air because it's like so cool. So that's great. And this AI knows about rain and it knows about fog, and it knows about red. And I also told it I want to see them from above and behind. So it knows about that. And then I said to AI, which it turns out that the thing that I'm most passionate about these days is I want to teach you object-oriented programming in the path to the master programmer. So let's ask AI to create a diagram that explains object-oriented inheritance. That's what I got. That's what I got from AI. Like, it's beautiful. I could never draw that picture because I can't even draw trees, let alone like a leaf, let alone trees, right? That is AI's concept of object-oriented programming. That is as dumb as a rock. That's as dumb as you can get. Now, I'll give it some points for the fact that, okay, there's buildings, and then there's actually conceptual buildings, and like, oh, that's kind of interesting, right? So buildings are a kind of archetype. So maybe it was smarter than me, right? Maybe this thing that shows me buildings as what OO means is actually really smart, and maybe I'm misunderstanding. But I choose not to think that way. I choose to think that instead, the AI is stupid, and that it knows a lot of things, and it knows about art, and it knows about colors, and it knows about fog, and I'm just like so excited about that. It is wonderful, and it's fun to play, right? And so that's the problem with AI. And so I think that if we look at current computer science curriculums, and I'll get back to this, I just keep hitting on this, I don't think that computer science is preparing you well right now as taught for a future in an AI-fueled world. So maybe the answer is quit taking computer science and instead take Dr. Chuck's path to the master programmer instead, because Dr. Chuck is preparing you for an AI-fueled world and computer science is preparing you for LeetCode. code. Mic drop. Okay, so yeah, Shabam, you're right. Shabam, you're right. AI can do the work, but you need to guide it just like programming. Okay, so let's see, where else were we at? Yeah, Carl, the idea is open source. I will, when I get farther down the road, I have to figure that part out. I have to figure out how to bootstrap people, and I'm actually doing that with some of my graduate students. I'm trying to teach that Java class that is that bootstrapping into complex software. I'm using my current graduate student employees for me to test that so I can get it to work at scale using my Sakai project. And so I'm testing it, but it's going to take me a while, and I want to finish the other courses before I pretend to teach the Java class. So let's see. Okay. Ooh, I'm going to sneeze. Sorry about that. There we go. Let's see. Where are we at? Oh, is there a document, Path to the Master Programmer, to look at? Just joined. Let me go find you that document real quick. Yeah, let me go find you that document real quick. It's in GitHub. I'm sorry. I'm like super old school. All my talks. So if you go into this URL and that's my 2024 talks, and you can see the Coursera Path to the Master. You can see all my talks, and this is the 319 talk that I gave. So if you want to see that, okay, let's see. Yeah, Augustine makes a good point. That Midjourney and DALL-E have gotten pretty dang good. Yeah, I'll get that. And I'm not saying they can't get better. I do think that I saw some stuff talking about the idea that people are starting to program LLMs with the output of other LLMs, and that's a dangerous thing because the output of the LLMs is as wrong often as it is right. And so I think what we're going to find if we come back in 10 years that that the LLMs themselves have started looking at each other and not looking at actual stuff that humans built in the first place. And when they start looking at AI generated stuff, then they're going to turn into mush. I mean, you're going to ask any question, and I predict like in 10 or 15 years you'll go into DALL-E. And if DALL-E lets itself look at AI-generated output, and increasingly we're starting to do it. In my PowerPoint, I had, let me show you. In my PowerPoint, let me find a PowerPoint. In my PowerPoint, I had somewhere, right there, that one right there. In that PowerPoint, that is AI-generated. And I have a concept, and in that concept of that picture, the prompt I told it had to do with show that looking at the syntax on a screen is not sufficient, but you have to see past the screen and into a 3D complex, intricate model of things like memory, subsystems, and operating systems, and networks, etc. So I wanted to show you something that goes behind it. So that I sit and play with that prompt over and over and over again because it is the core thesis of Master Programmer. And this is the best I've got. And it's a terrible picture. And it does not capture the concept of this three-dimensional thing that goes on behind the screen. I can see it in my head. I can't draw it, and AI can't draw it. But if AI now looks at this slide, because it can, and says, ooh, this is the concept of 3 dimensions behind a screen, because Dr. Chuck said so. And the answer is, no, it's not. It's the best of a series of exceedingly lousy pictures that I got from AI, and it's not good enough, and it doesn't capture the idea. But if you program the next LLM to look at this as if it's truth, eventually everything coming out of DALL-E is going to look like just a bowl of oatmeal, because it just crap, and then 4,000 craps, and the average of 4,000 craps is just crap, right? And so the danger is that these AIs are as smart as they might get dumber over time. because we're going to take them and we're going to publish what they give us as truth. And up till now, the AIs have not had the benefit of looking at other AIs. But when the AIs start looking at other AIs and they look at this crap, they're going to get dumber, not smarter. Because the output of AIs at this point is always a compromise. Unless, of course, you take a verse from Stairway to Heaven and say, generate me a Rembrandt-like picture of a verse from the Stairway to Heaven, and I'm going to put music on it. And the answer is, wow, that's profound. It's so awesome. It's not truth. It's not accurate. And the danger is that if you say these words mean this picture, even though we can enjoy that picture as an abstraction and listen to the music and like the picture, that doesn't mean the picture represents the thing that it's representing. It's just one wild, crazy interpretation of it. So AI is so fun, but I think we come back in 10 years and it's going to be lost. Just imagine if AI starts writing code and other AIs start learning from the code that AIs wrote, but like 95% of the code is right and 5% of the code is wrong. At least now people fix code and fix bugs, and AI can look at that and maybe learn from humans fixing stuff. But if AI just starts saying, generate this code, I'll read your code, you read my code, and we're just like, two wrongs do not make a right. And you just could come back in 10 years and AI could be absolute mush. And we might find that, these current, you might want to make a copy of the current Llama model, because this might be the last model ever generated that doesn't include the pollution of AI talking to AI. Just think about that for a second. Just think about that for a second. It's just bad. Yeah, Brent says that's why it's great for AI for Dungeons and Dragons, because the idea of a monster allows for abstraction. Absolutely. We're allowed to interpret. It's artistic. It's artistic as heck. It's so beautifully artistic, but that's not truth, and that's not knowledge. It's artistic skill. Okay. So somebody asked me a question, which is like the scary question. Where was it? CS50. Who asked me the CS50 question? Oh, Spring Boot. I'll be talking about Spring Boot in the Java class. So I will. That's going to be in there. Most Java is web-based stuff, so Spring Boot is a good place to start there. Somebody, there. Okay, I got to do this. CS. Okay, Amir says, what are your thoughts on what the CS50 team at Harvard is doing? Any thoughts on collaboration? So that's a good question. I think that's the first time I've been asked that question, because that says that you sort of know the lay of the land. So the first thing I don't like about the CS50 team, and I'll say good things about them too, but I don't like the fact that it's CS. So the CS50, the history of CS50, is it really comes out of one course, which is this really wonderful course at Harvard, and is taught by an economist and a computer scientist, both of whom are funny, articulate, and understand the notion of welcoming people into the field, right? And so they welcome people into the field, and they are a great recruiter for computer science. And so the first class in CS50, which is the one, if you watch some of the videos, they're just amazing. They have students running around the room pretending to be bits and stuff like that, and I've done those kinds of exercises when I'm doing face-to-face instruction about hardware, and and they do it right. They do it, that first class does it absolutely correctly. And so they make computer science, the foundations of computer science, they make them fun, and they make them interesting. And so the problem there is that they're doing what a lot of computer science educators are doing, and that is they are they are recruiting people into computer science with fun things, right? Oh, we're going to do a robot firefighter thing. So there's fire and robots and water and all this stuff. And so your first class is so fun. And so you're going to want to go into computer science. And they're going to increase diversity in computer science, which is a good thing to do in general. But then what happens is once you recruit them into computer science, they don't fix computer science, right? They don't fix the basic flaws that are computer science. As an example, the first basic flaw of computer science is the curriculum called CS1, which is their core curriculum. And the CS1 is interestingly based on this book. If you look at the CS1 curriculum, it's interestingly based on the C Programming for Everybody book. It's what I learned, it's what everybody learned, and we all think that that's core truth. And the answer is no, it's not good, because this chapter 6 of this book is why diversity doesn't exist in computer science. Because if you just teach chapter 6 as the same difficulty as chapter 5 in that book, you are kicking out anybody with even the remotest ability to be creative. You have to be so focused and so nerdy and so mathy to make it through the density that is chapter 6 in that book. Or you just quit and go be a business major or an art major or a barista at Starbucks. And so computer science is like, join. Oh, no, get the hell out, right? And so the key thing is and CS, again, because it's embedded in a computer science department, is doing a great job of bringing people in, but then not fixing the core curriculum that is flawed. Now, CS50 is a much larger organization than me, and CS50 steals my ideas all the time. I don't actually steal CS50's ideas. I did steal an idea from Rice University. So my first Python course stole ideas from Rice University. I also steal ideas from the poetry class, modern poetry at Penn, University of Pennsylvania, Al Filaries. So, but I don't see CS50 as doing anything better than me, except they have 35 people working on it. And so they can build a course faster than I can. They have fine teachers. They're doing fine. I think that their great limitation ultimately is that they're not willing to advocate to change computer science. And I am. And that's because I'm not in a computer science department. I'm in a school of information. And so I don't have to fight. I have delightful dear friends and colleagues in the University of Michigan Computer Science Department. And I can't win an argument with them no matter how hard I try. I can't. And I mean, and that's because I talk to like Mark. And I'm like, Mark, what class do you teach? Well, I teach 370, the architecture class. And I'm like, yeah, wouldn't it be great if we just made that class a lot easier so a lot more people could understand it? And Mark's like, no, you must understand it. It was taught this way 40 years ago, and it has to be taught this way. And he's good at it, and he's a great teacher, and he's a wonderful person. And if you're going for LeetCode, he's the right person to take the class from. And so the problem with is computer science is stuck with LeetCode. And they can't just say, I'm going to walk away from that, because the Computer Science Department at Michigan, Computer Science Department at Harvard, they're stuck producing LeetCode savants. And so they can't change their curriculum. I have the advantage that I'm not in a computer science department, just like CS50. And so I am going to find a path that is not a path that worships computer science dogma and submits myself to computer science committees to say, you're not computer science enough. I'm like, yep, I'm not. And the problem with Harvard is that they are still pretending. Georgia Tech had some really good computer science work. But again, it was all about drawing people in and then giving a bad curriculum, in my opinion. And so that's like, and you see like CS, Computer Science for All, and all these like really well-intentioned things that are not intended to fix computer science in the least. They're intended to increase the demand for computer science so people will tolerate the crappy curriculum that is computer science. And so I probably exaggerate to make the point. It is so that's me and CS50. I think that they're the second best in the world, and that's okay. And they keep me on my toes. I can't rest because I can't rest because if I wait, they're gonna run me over, and CS-free, CS50 ended up with my long-term strategic plan because I wasn't very good at hiding it. And so CS50 has already built some of the courses that I want to build because they were handed my long-term strategic plan. And it didn't bother me because I'm happy for them to do some good stuff and steal all my ideas. But I don't feel the need to steal their ideas because they stole my ideas. So, yeah. So let's see. We're running out of time. Get a couple here. AI can do simple things very fast from my experience. Completely agree. So, Natalie. Hey, Natalie. So Natalie, so you're doing C programming for everybody, right? So I'm going to do something in C programming for everybody that I've never done before. And so you can tell all your friends, I am going to try in C programming for everybody twice a month to have interactive online office hours using Zoom. And I will invite students who are currently taking C programming for everybody into a Zoom room. We'll see how it goes. So expect, if you're taking C programming for everybody, that there'll be something different in there, which is, this is a YouTube stream, so I can handle hundreds and hundreds of thousands of people in YouTube streams, right? That's easy. And you're all talking in the chat, and I feel like when I look at it, I read the chat. I'm going to actually try real office hours the exact way I do them on campus, except in C programming for everybody. And I'll start with at least 2 one-hour sessions per month. The way you find out about those sessions is you're in C programming for everybody, and I will send you email with the joining information on those. And I'll probably start that in a week or so. And so if you're in C programming for everybody, any of the 4 courses in C programming for everybody, and then here's the interesting thing that I might do. If it goes well in C programming for everybody, I may start opening it up to some of the other specializations. I won't open up to Python for everybody because that's 1,000 people a week, and that won't work. But what I may do is I may open it up to, second, third, and fourth class in Postgres, second, third, and fourth class in Django, second, third, and fourth classes. So if I enjoy it and it doesn't seem like it's too chaotic, if I let you all in and you get to talk, and so I just part of the reason I want to do that, especially in C programming for everybody, is C programming for everybody is not a difficult class, but if you needed to slow down in Python, you really need to slow down. I think some people could take over a year to work on C. And so part of it is I'm like, okay, this is one of my most advanced classes I've ever done, even though it's accessible to anybody. I feel like I need to be in the class, and I need to hear what you're struggling with in that class. So I need to hear from you, and I want to be able to screen share. I want to be able to talk to you. The enrollments in C programming for everybody are not so high that I can't tolerate that. So that is my new experiment. So if you're in C programming for everybody, or you're joining C programming for everybody, then we'll do another experiment. Now these live things that I'm doing right now, at least once a month. And so we'll see how it goes. Yeah, the AutoGen is an interesting idea. Fix its output. So, okay, let me see if there's one more question. I like this one. Let me go to this one here. Amir, the AutoGen is an interesting idea that has AI go back and fix its output. Right. So I had AI build a web crawler, which is actually a classic thing that AI does, and it was amazing. I had built one, and I thought, you know what, I'm gonna start over, and I'm gonna have AI build my web crawler, and I really, because I'd finished building it. It was in PHP, and I'd finished building this web crawler, and I'm like, you know what, I was actually starting to write the documentation on how to use this web crawler, and I thought, I wonder what happens if I take this documentation that I'm writing about the README for the web crawler. What happens if I take this documentation and I paste it into AI, ChatGPT at the time, this is a couple months ago. And so I pasted it into ChatGPT, and it starts writing code, and I'm like, whoa, that looks like the code I already wrote. That's pretty good code. So I'm like, okay, let's see how far this rabbit hole goes. So I took the code it gave me and I put it in, and it was good code. It kind of worked. And I'm like, oh, you're using in-memory arrays. Could we just make this be a restartable crawler? He's like, yeah, sure. So it makes a database, and I'm like, you put it in SQLite. And so it's putting stuff in the database and pulling the stuff out. And I'm like, holy crap. And because I'd done the same thing, right? And it's like, man, this took me like 4 days to write, and I'm sitting here like an hour in, and I'm actually at day 3 already. And so I'm copying this code back into my thing, and I'm running it. I'm like, you are so awesome. And then, after about like 10 prompts, the code was pretty good, except it had one bug. And I'm like, this code, then I started talking to ChatGPT. And I'm like, yeah, this code is great, but it's got a bug in that it actually doesn't start the right way. It doesn't bootstrap itself the right way. And it goes like, oh, that's okay. I'll rewrite the code. I'll just, don't worry about it. I understand. Here, let me rewrite the code. So it rewrites the code. And it's the exact same code it wrote before, but it did apologize for getting it wrong and said it would rewrite the code, and it wrote the same code as before. And like, okay, I guess I better take a look and figure out what this problem is. So I look at the code and I figure out what the problem is. And I'm like, hey, ChatGPT, the line that I think is causing the problem, and I paste it in this line. So could you rewrite it and fix that line of code? And it goes, yeah, I am so sorry that I got that code wrong. Let me rewrite that for you. Yeah, thanks, man. I'll get it right to you. So it rewrites it, and it doesn't change anything. And I'm like, look, I think it's the 5th parameter to the function call in that line. Could you rewrite it and fix the 5th parameter of the function call in the line? It goes, yeah, don't worry. I'll rewrite it. It gave me the exact same code back. You see how this is going to end, right? Finally, I say, I think if you pass in null as the 5th parameter of the function call on line 67, the code will work. It goes, yeah, I got it. Thanks for that. It gives me the exact same code with the bug. And at that point, I quit asking questions, right? And I worked on that code after that, but it is not a software developer. It's a large language model. It has read a lot of things and made wonderful connections between all those things. It's seen a lot of patterns. It's stared at a lot of things, and it can get you somewhere so fast, but you still got to finish the job. So, okay. Had a good question about Linux. Yeah, I should teach a Linux course, and I can't say you're wrong. And so one of the things I do in Python for Everybody is it's a secret hidden Linux course because you're using, Django for Everybody. It uses Python for Everybody, which is a Linux system. You do all your homework in Linux, and I probably should add some lectures to that. I have a couple lectures about how to use Linux and a quiz about how to use Linux, and so I will. I should probably add more to that because that's a wonderful opportunity to teach Linux, and I use any opportunity that I can to teach Linux when I can because I think Linux is a core skill, and so maybe the 8th course will have to be Linux because you really can't work in the cloud without knowing Linux. I mean, that's the good news. We're not using Windows servers in the cloud. We're not using VAXs. We're just all using Linux. And so the basics of how to edit files, how to navigate directories, what a shell is, how to configure your shell, how to use Nano and how to use VI and how to use Emacs, those kinds of things are, I think, core essential skills. So yeah, I agree. I agree with you about Linux. Let's see. How come it's not? How come I'm not? Oh, there we go. Yeah, I think. Okay, I think it's time to wrap up. So, thank you all for coming. This is first of what I hope is many live events. I have this really cool setup in my office. That allows me to I just hit buttons. You'll see me leaning forward and changing things. I got a live handheld camera. I didn't use it today. I got a single button to start the stream and stop the stream and all that stuff. And so I tried to make it as easy as possible for me to do a stream. So one of the things that that you'll see is I'm going to start streaming coding. It'll be boring. I mean, if you look at my Dr. Chuck Plus thing, you'll see an hour-long code on Sakai. And it turned out better than I thought. I won't be interacting this way while I'm live coding because I'm just live coding. It's very zen. And so we'll see how it goes. But I've set this up to make live streaming not too hard. I figured out how to do a countdown at the beginning, and that all worked, and my audio works. And so that's really good. And so with that, I will sign off and see you all next time in the stream. Cheers all.